Hello everyone. The final decision-making approach that we will use without the use of probabilities is known as the Minimax regret approach. And this is the most involved of the three methods that we will look at, but hopefully we'll see it's really not that bad once we find out what the inner workings of the method are. So again, we'll look at both a profit example and a cost example with the exact same numbers so that we can see sort of how this method is going to work between the two. So let's begin with the profit example. Unlike the other two methods, where in the other two methods, the first thing we did was we looked at either the best case scenario or the worst case scenario for each decision alternative. I would have gone decision by decision and picked either the best or the worst case scenario, depending on whether I was doing conservative approach or optimistic. Here, that's not what we're going to do yet. The first thing we have to do is to create something called a regret table. So as we said, step one is creating the regret table. And it's going to be, let me just copy and paste this for ease sake. Control V. Okay. But now what we're doing is we're not looking at the best or the worst alternative for each sort of decision as we did before. Remember that we were looking along each decision alternative. So we started by looking in the rows. This is the only method where we're not going to do that. What we're doing here is we're looking first by the states of nature. So each individual state of nature I'm going to deal with first. And I look at what is the best option, what is the best thing that can happen for state of nature 1 that I'm working on here. And since we're talking about a profit example, the best thing that could happen is that we earn a profit of 16 units, whatever those units are again. So what we do now is for each of the other payoffs associated with state of nature 1, we do a subtraction between the best possible option and that individual option. So if I'm talking about, for example, here I'm looking at a payoff of 10, and we're looking for simply the absolute difference. No negative sign. The difference between 10 units and 16 units, if I do that subtraction, we end up with 6. So this value, okay, as we said, this value will only ever be the absolute difference between the best option for that state of nature in that individual payoff that you're looking at. So again, a difference of 6 units between 10 and 16. So we would always have positive 6, absolute value, never a negative sign here. Okay, similarly, the difference between the payoff of 14 units and 16, the best option for that state of nature would be 2 units. And always there will be a 0 difference between the best option and itself. So we've created this for state of nature 1. We're going to do this for each of the other state of natures. So again, we look at the best option, which in this case would be a profit of 24 units. So 24 minus 24 is 0. 24 minus 20 is 4. 24 minus 17 is 7. And finally, we do that for the last option as well. Again, paying attention that this is the only one where I'm going column by column to begin instead of row by row. So again, we notice here the best option is now 29, and doing our subtraction each way, the difference between 29 and 20 is 9, 0, and 3. But now, for the second part of the table, we are now looking for the maximum regret. Okay, the maximum value here. So as we said, now we're looking for the maximum regret. But now here we are going, once again, row by row now. So now we're doing it for the decision alternatives. So we started, this was the only method we started doing it column by column, but now once again going row by row, and we see the maximum regret here is 9 units. The maximum value for D2 is 4 units. The maximum value for D3 is 7 units. And in this case, so we found the maximum, that's the max in the minimax part. Now we need the minimum, Well, the minimum value here would be D2 is the smallest value we see amongst the maximum regrets. Our decision here would be to choose D2. Now we think of this. Think of that 4 units, okay, or any of these units. If I look at the 9, what this is really saying is, remember that all this stuff is based on uncertain things that are going to happen in the future. What this is saying is that if we chose decision 1 and things did not go the way that we wanted them to, there was an option that would have given us 9 units more profit. So choosing decision 1, there was a potential option where there was a better choice that would have given us 9 units more profit. If I chose D3 and things didn't go the way that we thought they would or we wanted them to, there was a potential other option that would have earned me 7 units of more profit. Whereas with D2, even if it was the wrong choice, the worst that could have happened is I lost out on 4 units of profit. And since it has the least amount of regret, the least amount of potential lost profit, that is the decision alternative that we choose. So I would do the same thing here. I would do the same thing if this was a cost example. Let me just copy this over. So again, we're going to start in the same way with the Minimax regret approach. We're going column by column, looking for what is the best possible payoff, depending on the scenario we're dealing with. And here we're dealing with cost. So the best scenario is to have the lowest cost possible. So for state of nature 1, that would be a cost of 10 units. And then we do a subtraction between that best possible payoff for that state of nature and all the other payoffs for that state of nature. So 10 minus 10 would be 0. 10 minus 14, and remember that we only use the absolute value. So whether I do 10 minus 14 or 14 minus 10, what we're talking about is a difference of 4 units between the best payoff and that particular payoff. So here the difference would be of 6 units. As we go to state of nature 2, the best possible payoff, or again in this case, as always, the lowest payoff because it's cost would be 17. So looking at our differences, we have a difference of 7, of 3, and of 0. And then finally for state of nature 3, the best payoff in terms of cost would be a cost of 20 units. So again, our subtractions, a difference of 0, a difference of 9, and a difference of 6. Once again, once our regret table is created, the next thing we look at is our maximum regret for each decision alternative. So now we are looking at the decision alternative. The maximum regret we have for D1 is 7 units, for D2 is 9 units, and for D3 is 6 units. And once again, we want to choose the minimum value here. The minimum value in this case being D3 would be the alternative we would choose under this decision-making criteria, the Minimax regret approach dealing with cost. The way we kind of think of this is for D2, if I look at D2, that 9 units, again, this means if we chose to go with D2 and those uncertain events in the future did not work out the way that we thought they would, we could stand to pay an extra 9 units of cost over and above better possible choices that would have existed. Similarly with D1, if we chose D1 and it wasn't the right choice, we could stand to pay as much as 7 extra units over better potential alternatives. Whereas with D3, the worst we could do, even if it was a wrong choice, is paying a cost of 6 units extra over better possible alternatives. And since that is the least of those maximum regrets, that would be our decision choice under the cost example. So again, a little more work when we have the Minimax regret. The first thing we have to do is to create that regret table, right? This is the only time we are going state of nature by state of nature, column by column, instead of row by row like we started the other two. And after we created the regret table, it is now very much similar to what we kind of saw with either the optimistic approach or the conservative approach. We look for the maximum value, row by row now, so decision alternative by decision alternative. And then once we have those maximum values for each decision alternative, we want the lowest possible option. The option that if things do not go the way that we think they will have the least potential to harm us. Thank you very much, everybody. I hope that makes sense. Please email me any questions that you may have.